Now, whenever you are designing the synchronization mechanisms, you should see that your solutions should follow some conditions, which means after designing the solutions, you verify that these rules are followed by your solution. So there are 4 rules, and 2 are very important, and 2 are not, very important. But then it is better if you have them. I mean, if your solution is having these 2 conditions as well. First one is, if a solution should definitely provide mutual exclusion. That is why we are doing it. What is mutual exclusion? If one process is in the critical section, then the other process should not enter the critical section. That is mutual exclusion. It is like this. You can think of it like this. We have a room, and the room can be used only by one person at a time. Maybe you could think of it like a changing room, dressing room. Okay, let us say there is a dressing room, and now only one person can get into it, and at the same time 2 people can't get into it, right? Therefore, what you should do is, you should come up with a solution in which you will allow only one person to get into that room, right, at any time. And once that person comes out, then only you can allow the other person into the dressing room, right? So that is called mutual exclusion. Therefore, it is very important that your solution should definitely provide the mutual exclusion, otherwise there will be race conditions, right? And now second thing is, progress should be guaranteed. Progress is like this. You could think of it like this. Now you have a dressing room, and there is no one who wants to get into the dressing room. And now if let us say there are 2 people and there is single dressing room, and person 1 doesn't want to get into the dressing room, then he should not stop person 2 from getting into the dressing room, which means, see this is the dressing room. So in our concept, critical section is nothing but the room. Okay, so this is the critical section, which is nothing but dressing room, and now there are 2 people, right? So what is mutual exclusion is, only one person should be inside the dressing room at any time. Only one process should be inside the critical section at any time. That is mutual exclusion, right? You cannot put 2 people at the same time, isn't it, in the dressing room, right? Then if that is the mutual exclusion, then what progress means is, let us assume that this person doesn't want to get into the dressing room. Now he should not stop other person who wants to get into the dressing room enter it, right? So if a process doesn't want to get into the critical section, then that process should definitely not stop other processes which are interested in getting into the dressing room. Which means, if this is the critical section and dressing room, both are you can metaphors right here. Now what I mean to say is, if this person doesn't want to use the room, he should not stop other one from using the room, right? And these 2 are very important. Your solution should, whatever solutions you propose, your solution should always follow these 2 rules, and the other rules are like this. So if your solution is not providing these 2, then we are not going to implement it anyway, because these are very important, and we'll search for other solutions which will provide us with this. And now other one is, second is bounded waiting. Bounded waiting means, if this is the room, right, you should not stop a person for a long time, which means if he enters the room and again she too wants to enter the room, once he comes out, she should be given the chance. Or at least you can say, you enter one time and then you can enter one time, or you can say you enter 2 times and then you can enter one time, or you can say you can enter 3 times and you enter one time. But you cannot say that he can enter infinite times and then he can enter one time, she can enter one time. So if you say this, then it is nothing but there is no bounded waiting, right? Bounded waiting is nothing but you should be able to say after how many times at least you will get a chance. If you are able to say that, then the other person will happily wait. It is not that the other person will continuously be, one person will continuously be going into the critical section and the other process will wait forever, right? So bounded waiting should be guaranteed, and it is a secondary need. Even if you are not providing bounded waiting, there will be starvation. Okay, we are fine with that, right? Starvation means one process will wait forever. We are fine with that. So it is not primary requirement, it is secondary requirement. And the other one is portability or architectural neutrality. It means that you should not make any assumptions, right? Assumptions that this solution will run only on this operating system, or this solution will run only on this hardware. Sometimes what happens is, some solutions you propose will be so much dependent on the architecture. Like they will depend on the operating system you are using, or they will depend on the hardware. For example, some solutions will require that your hardware supports some instructions, and if your solution is going to use the instructions provided by the hardware, then if you try to implement the same solution on some other hardware, it might fail because the other hardware might not have these instructions, right? Therefore, it is very important that you should even keep this architectural neutrality. Whatever solution you propose, that should be able to run on all the platforms, but then it is not very important, right? Which means it is a secondary requirement. Understood this? So mutual exclusion means only one person in the room, and progress means if one person doesn't want to get inside the room, then he should not definitely stop the other people from getting into it. It is like this. There is an example, I don't know whether you know it or not. They say that if there is a room full of grass, it is containing bundles of grass, right? And there is a horse. Okay, I can't draw the diagram. There is a horse and there is a dog, isn't it? Now, dog doesn't eat the grass, isn't it? But if the dog is stopping the horse from getting into the room, right, that is a problem. Why? Horse wants to eat the grass, but dog is stopping it, and dog doesn't want it, right? That is called progress. Progress means the dog should not stop the horse because horse wants the grass, but dog doesn't want it, right? So if a process doesn't want to use the critical section, that process should not stop the other process from using it. And now what is bounded waiting is like this. If one person should at least say, okay, let me go inside the room 2 times, then you can enter it 1 time, or let me use the room 10 times, then you can use 1 time. You should at least be able to say that after some particular amount of time, or after letting the other process get inside the critical section for some number of times, the other one should at least get 1 chance. If you are not able to say any such bound, then we can say that there is no bounded waiting. Bounded waiting means you are waiting, but that waiting time is bounded by some constraint. If there is no boundedness, then you are going to wait forever. That is going to lead to starvation. Anyway, it is a secondary requirement. And the third one is architecture neutrality, which means it is like this. Your solution works only for one room and it will not work for the other room. Here in that case, your solution works for only one platform and it will not work for the other ones. So anyway, we shall examine all these 4 conditions for every solution that we propose. Now we are going to see lots of solutions and we are going to observe them. And anyway, these synchronization mechanisms can be again classified into 2 types. One is synchronization mechanisms with busy waiting and synchronization mechanisms without busy waiting. So what is busy waiting and what is without busy waiting is, you can think of it this way. As I was saying, these synchronization mechanisms are of 2 types. One is with busy waiting and other is without busy waiting. So how can we compare it to our metaphor that we are following? The dressing room is, if you compare this critical section as the dressing room, and if one person is inside the room, right, busy waiting means the other person who wants to enter the room will continuously be knocking. If she doesn't want to enter the room, okay, fine, she will not do anything. In case if she wants to enter the room when other person is already inside the room, she will be standing at the door and she will be continuously knocking, asking whether he is still inside, continuously, right? And it is a waste of time. So what is this knocking in terms of the CPU is falling in an infinite loop. So this process is going to fall in an infinite loop, and whenever it is scheduled for for the CPU execution, it will continuously do nothing. It will be busy in the infinite loop. That is why it is called busy waiting. Busy waiting means you are not doing anything. You are standing there busy, knocking the door, just waiting, busy, but then busy, isn't it? Similarly, the process will be at the CPU just running that infinite loop and not doing anything else, but then it will not leave the CPU until the scheduler pulls it out, right? And what is without busy waiting is, now whenever one person is inside the room, if she wants to enter the room, she will see one time that someone is inside the room and she will go and sleep. She will go and sleep here, right? Sleeps. And now whenever this person comes out, he will wake up and then she will go inside. Got it? So what is the difference between busy waiting and no busy waiting is, one thing, without busy waiting means you are not going to stand there and knock. Obviously it is better, right? Because you are not wasting the CPU time, you are not continuously knocking, you are just going and sleeping. And now what I'll do is I'll take the mechanisms which are in with busy waiting as well as without busy waiting, and then I explain you the mechanisms. Then we shall see if the mechanisms are following that four constraints, and then we shall solve some problems. That is the way I'll take it. Okay, so even if you didn't understand anything, whatever I told you now, with examples it will be very clear. Fine.